A multidimensional array is simply an array where each member is also an array. For example, this is a diagram of a two-dimensional array. It's 5 elements wide by 4 elements high. Now in C, an array of integers of this size could be declared this way. In assembly language, you only need to declare a block of memory big enough to hold it. It becomes an array because you address it that way, to read data from it and write data into it. The size is the number of elements times the size of each element. So the question comes now, how do you address an element of a multidimensional array? It's easy, really. The truth is that the whole thing is one long array of integers. You just have to think of it as rows and columns. For example, say you want to address the third member of the first row. Now in C, that would be the item addressed this way. In assembly language, you could address it the same way that you address a two-dimensional array. It could be the base address plus the index times the size of each element. Okay, let's go a bit further. Say you want to address the middle member of the bottom row. In C, it would be addressed this way. In assembler, there is a bit more work to do. You calculate the address this way. Or another way to write the same thing is like this. In simple terms, you calculate the number of items that come before the one you want. Then you multiply that value by the size of each item, then add the result to the base address of the array. In this example, to address item 3.2, you would simply calculate the address this way. As you can see, it's nothing more than a base address plus a constant. And you can have more dimensions all you want. Just keep extending this algorithm to fit what you've got. However, my experience has been that you almost never need more than 2. Anyway, here's this example in assembly language. The first thing to notice is the declaration. It's a simple block of the right size. In this case, it's a block of 20 32-bit values. It becomes a two-dimensional array simply because it's addressed that way. This code places a value 32 in location 3.2. There are 5 items per row, and we just skip down 3 rows. Then the offset into the target row is added. Finally, the number is multiplied by the size of each item in the array. This constant offset is then added to the base address of the array, and the value 3.2 is stored in the location. The return value, the address of the array, is then stored in the EAX register. A C mainline program calls the function and displays the values as one long array, and you can see where the one item in the array was addressed and modified.